In this video, we just want to continue with some more examples of finding first-order linear differential equations or solving first-order linear ordinary differential equations. So let's continue on. So as before, we want to write everything into standard form. So this means we need to divide by t squared minus 9 everywhere. So we get the derivative of x with respect to t plus t over t squared minus 9 times x is equal to, all right, we have the square root of t squared minus 9 over t squared minus 9. This means we get 1 over the square root of t squared minus 9 once we divide everything there. All right, and so our integrating factor is always e raised to the integral of p of t. Here, p of t is t over t squared minus 9. So the first thing we want to do is integrate t over t squared minus 9 with respect to t. Well, we can do that with a u substitution, right? If u is equal to t squared minus 9, du is equal to 2t dt, or in other words, du over 2 is equal to t dt. So we replace t dt with du over 2. So this tells us we get 1/2 times the integral of du over, and t squared minus 9 becomes a u. Well, this is 1/2 the absolute value of ln of the absolute value of u plus c. Again, we don't need that plus c. So we get 1/2 ln of absolute value of u, which is 1/2 ln absolute value of t squared minus 9. And for some reason, it's being a little slow writing this. There we go. And we get that. Okay. So we then can move on to finish out our problem. So I'm going to go ahead and erase this. And again, our integrating factor was e raised to that integral, which was 1/2 ln of t squared minus 9, which is e raised to the ln of t squared minus 9, all raised to the 1/2, which is t squared minus 9 raised to the 1/2, which means just square root of t squared minus 9. So that is our integrating factor here. This is our mu of t for this problem. Okay, so we multiply everything by that. If we multiply the left-hand side of our standard form of the equation, of our differential equation, then we get the derivative of this product, which is always the integrating factor times x. And the right-hand side, well, the right-hand side was 1 over root t squared minus 9, but we're now multiplying by our integrating factor, which is root t squared minus 9. So this becomes 1 in this problem. Then we integrate both sides. Our left side just becomes the square root of t squared minus 9 times x. And the right side becomes t plus c, which is the solution we have written down here. But really, we want to solve for x. So this is t over root t squared minus 9 plus c over root t squared minus 9. And that is the solution to our differential equation. We have one more example we're going to run through here. And so let's do that now. Now we're going to solve the initial value problem. So we have some function here. And we want to solve that initial value problem. So we have x prime plus x over t is equal to cosine of t divided by t. That's our differential equation. But we have the initial value that x of pi over 2 is equal to 2. Remember, x is a function of t, right? So that x of pi over 2 means t is pi over 2. When t is pi over 2, the function x is 2. So, well, we're given the function in standard form this time. So p of t is 1 over t. So we want to integrate 1 over t dt, right? We're integrating p of t to find our integrating factor. Well, we get ln of the absolute value of t plus c, but again, we don't care about that plus c at this point. So really, the integrating factor is, how about I write that out? The integrating factor, mu of t, is e to the integral of 1 over t dt, which is e to the ln of t, which is just t. So we get that. Now, we then move on and we multiply everything by t. So we get t times x prime plus x. Well, that is, of course, on the left-hand side, that is always the product of our integrating factor, which is t, times x. Sorry, the derivative of our product of the integrating factor times x. And then we multiply the right-hand side by t as well. Well, cosine of t divided by t times t is just cosine of t now. So we get that. Then we need to integrate both sides. We integrate the left side, that we're always just going to get t times x, or the integrating factor times x. Integrate the right-hand side. The integral of cosine is positive sine. And of course, we integrate, so we get a positive c out there as well. Now, let's try to find out what c is. Why are we doing that, right? We have a initial value problem. We're solving the initial value problem. So to do that, we need to find out what c is here. Okay, so we have t times x is equal to sine of t plus c. That was our function. I'll rewrite that here. Is equal to sine of t plus c. But here we have this extra piece of information that x of pi over 2 is 2. So when t is pi over 2, x is 2. So we get that expression. Pi over 2 times 2 is pi. Sine of pi over 2 is positive 1. So c is equal to pi minus 1. So our solution then is tx is equal to sine of t plus pi minus 1, or in other words, x is equal to sine of t over t plus pi minus 1 over t. And that is our solution to the initial value problem. And that'll also end this video.